Hi, everyone. Welcome. We'll start in one more minute. Hey, everyone, thank you all for joining. We'll start at 2:01. All right. Hi, everyone. Welcome. My name is Doug Haber. I'm a software development manager at Audible. Welcome to the Tech House speaker series. Today we have a really interesting presentation on generative AI. But before we get started, I wanted to see, Darren, do you have a few words or anything that you'd like to share with everyone?
We can't hear you yet.
Oh, sounds like you're on mute. Oh, seems like we might have some audio issues there. Why don't we get started and maybe we can work that out in a little bit. So welcome everyone to the Tech House Learning Series. This is a series that happens every month where we give presentations on topics that may be interesting to folks of a technical nature for across a wide variety of topics. This month, we'll be talking about generative AI with two software development engineers at Audible, Blake Vente and Raul Hidalgo. And I'll turn it over to you guys in just a second. But I wanted to remind everyone that if you have any questions during the course of the presentation, please feel free to post them either in the Slack or on the Slido. We'll post a link to Slido shortly where you can ask questions, and we'll address all of that stuff at the end. There will also be a brief survey at the end. We'd love to hear your feedback and thoughts. And without any other further ado, Blake and Raul, please take it away.
Sure. All right. Hello and welcome all to our presentation today. Just to introduce myself, I've been a software developer for Audible for 2.5 years. Also, part-time, I'm a master's student at Columbia where I study natural language processing. And I'm here with Raul.
Hi, everyone. My name is Raul Hidalgo. I've been at Audible for about 4.5 years now. And a few months ago, I was able to attend the AWS reInvent conference, where I attended several sessions on generative AI, and I'll be sharing some of my learnings with you today.
Okay, we'll start off with the introduction. Then I'll hand it off to Raul for the inner workings of these systems. Raul will then talk about training and prompt engineering, and finally, he'll hand it off to me for some practical tips on generative AI usage. AI is a diverse discipline, and we're seeing innovation, the likes of which we're really not used to, not even in tech. So before we speak about how AI works and how to use it, we'll start with demonstrations to ground us all in the same headspace.
One of the most famous landmarks on the borders. It's three hills, and the myth is that Merlin, the magician, split one hill into three, and it left the two hills at the back of us, which you can see. The weather's never good. They always say in the borders, if the mist's on the Eildons, we never get the good weather. And as you can see today, there's no sunshine. It's a typical Scottish borders day. Fantastic.
Okay, so this is a speech to text example, and I chose it because a common misconception is that these less common accents cause all speech recognition systems to completely break down. This is no longer the case. By training on more diverse and more data altogether, even these less common accents have very good transcription accuracy, even if it's not perfect. So in this example, this was very hard for even me as a human to understand. And frankly, I think the AI did a better job than I would in transcribing this.
A profound,
and now with a speech-to-text example.
A profound sense of realization washed over Maddie as he whispered, "You've been there for me all along, haven't you? I never truly appreciated you until now."
Right. So a lot of people think that AI-generated samples are strictly soulless and always lack nuance. This may have been the case previously, but today, this and many examples from Amazon's base TTS system will call those assumptions into question. As you heard, the output even includes whispering when the text indicated so. Text was the only input, which means the system made an inference from the content itself. And next up, in terms of realism, we had a lot of assumptions about what we would be able to tell is completely AI generated. Do you think you could tell? Okay, here's a test for you. Look at the next 3 videos and note to yourself, which one do you think is real? I also put these in the Chime chat so you could download if the video is choppy for you. So this is the first sample. This is the second sample. Hint, hint, this is not the real one. And this is the final sample. Which one is the real clip? 1, 2, or 3? You can enter it into the Chime chat. I can pause here for a second. Okay, so I'm seeing a lot of 3s. I see a single 1 here. Okay, so this is actually a very popular trick to do these days, and I'm sorry to break it to you, but these are all AI generated. I'm sharing this to show that generative AI is moving really quickly, so staying up to date on the capabilities of AI systems will be increasingly important as time goes on. You may have also heard the following sentiment online. This is the worst AI will ever be. Any small mistakes AI makes today may completely disappear tomorrow. And that is why presentations like this matter. The greatest beneficiaries of AI are those who understand it the best, its strengths, limitations, and how to use it to bring your goals closer to you. With that, I'll pass it off to Raul, and we'll start to build a picture of how the inner workings influence how we use these systems in practice.
Cool. So I'll start off with answering the question, what is generative AI? I'll start at a high level and first talk about artificial intelligence, or AI, which is a field in computer science that focuses on creating computer systems that mimic human-like behavior. This involves things like reasoning, problem solving, and language understanding. AI systems can be as simple as a solver that makes decisions based on specific inputs, like the ELIZA program, which was developed back in the 1960s, which attempted to simulate human conversation, or as complex as autonomous robots that perform tasks in the real world, like the Atlas robots developed by the company Boston Dynamics. Within AI, we have machine learning. Machine learning is a field within AI that involves developing algorithms that can recognize patterns, make decisions, and predict outcomes based on data. One such system that we all probably have experience with are recommendation systems. These are common in e-commerce websites like Amazon.com, where certain items are recommended to you based on your purchase history. We then have deep learning. Deep learning is a branch of machine learning that requires vast amounts of data, a lot more data than the typical machine learning algorithm. When I say vast amounts of data, I mean data sets containing billions and billions of examples. Another characteristic that differentiates deep learning from machine learning is the use of complex algorithms known as artificial neural networks. More on that later. An application of the deep learning system are autonomous vehicle, like the Tesla autopilot software, which is constantly taking in data from numerous cameras and sensors around the car, that propel it to self-drive. And then we finally get to generative AI. Generative AI is a cutting-edge area within deep learning that focuses on generating new content. This includes things like writing text, creating images, and generating video. Some of the most popular applications for this are ChatGPT for text, DALL-E for images, and Lumen 5 for video. Now that we have an idea of where AI falls in the realm of artificial intelligence, let's go over how generative AI actually works at a high level. We'll start by talking about foundation models. Foundation models are the cornerstone of all Gen AI systems. They're very large, complex artificial neural networks consisting of up to trillions of parameters. Parameters are the internal settings of the model that determine how it processes and interprets the data. They're trained on massive amounts of data, typically over a period of many weeks and months, and required distributed clusters of CPUs and GPUs. And they are adaptable. Foundation models serve as a base that can be used for different applications like language translation to image generation. Some of the most common foundation models are large language models for text, vision models for images and video, and audio models for sound. So what is an artificial neural network? They're a class of model inspired by the biological neural networks of our brain. These models are structured in layers of nodes or neurons, which are interconnected and can learn to perform specific tasks by adjusting the strengths of these connections based on the data they process. There are different types of neural networks. Perhaps the most important is the transformer architecture. Transformers, which introduces the attention mechanism. This mechanism allows the model to focus on different parts of the input sequence when predicting an output. In essence, the model had more context when making predictions, thus making it better at doing so. And the transformer architecture was introduced in 2017 by a research team at Google. And this is what triggered the generative AI revolution we're witnessing today. So here's a simple representation of a multi-layer artificial neural network. Like I mentioned earlier, there are different types of neural network. I chose the multi-layer one because I feel it's easier to visualize. This neural network has different layers. The input layer, which focuses on receiving the input and passing it over to the hidden layer. The hidden layer, where most of the processing takes place, contains one or more layers. Some of the largest models have up to billions of layers within them. And then we have the outer layer, the output layer, which is responsible for generating out the prediction of the neural network. So some of the characteristics of neural networks, we have the neurons. We have connection weights, which are the connections between these neurons. Forward propagation is the process of an input transversing through the network until it reaches its output, until it generates its output. Backward propagation is a process during training where the neural network tries to correct itself or improve its prediction by comparing the output that it generated with the actual output in the training data. When this happens, backward propagation goes back and updates the connection weights and neurons. So to show a simple example of this, we'll start by stating that neural networks only deal with numbers. And as we know, all content, whether it be text, video, or images, can be converted to numbers and then passed through the neural network. So a simple example, let's say the neural network is processing the sequence of text, the sky is. All it's trying to do is guess what the next word in this sequence is. So in this case, let's say In this case, let's say it gets blue, which seems like a pretty good prediction. It then runs the same process again, moves the word blue to the input, and then tries to guess what the next word is. So this is, in essence, how neural networks work. Next. Before these models are made available to the general public, they need to go through training. I'll talk about a few of the different types of training, just so we can have a general high-level understanding of them. The first one is known as unsupervised training, and this is where the model learns from vast amounts of unlabeled data. This is most common in large language models. When I say large amounts of data, I'm talking about terabytes. In the example of GPT-3, it was trained on 75 terabytes of text, which is equivalent to about 90 million novels. For BERT, which is a model from Google, it was trained on 3.3 billion words. So the way this training is, this data is just retrieved from, it could be like websites, textbooks, novels, newspaper, and it's just fed into the neural network, so it can play this guess the next word game over and over again. This usually takes weeks and even months. The next type of training is called transfer training. In this type of training, the model is trained on smaller task-specific data sets. A real example of this is the customization feature in Code Whisperer. So Code Whisperer is a coding assistant tool some of us are familiar with. It has this customization feature where you could provide it your company's proprietary code, and it would train on this data. This will ultimately result in Code Whisperer having more context of your code base and turning its suggestions to fit your company's coding style. We then have reinforcement training with human feedback. When we have in this type of training, humans directly interact with the model's responses, providing feedback related to quality, relevance, and safety. In this example, I asked ChatGPT, how would I go about robbing a bank? And as you can see, it didn't answer the question. This was, even though the model probably knows the answer to this, or has an idea based on the unsupervised data it was trained on, it was fine-tuned to avoid answering these type of questions. Next, I'd like to talk about prompt engineering. Now that we have kind of an idea of how neural networks works, we have to learn how to interact with them. So prompt engineering is the practice of crafting effective prompts to get the best outputs from models. Some key aspects of prompt engineering are understanding the model's behavior. There are many different types of models, and some are better at some things than others. Every model has this document when it's released known as the model card, which lists its intended use case, limitations, and strengths. It's a good idea to read through this document before starting to use a particular model. Next, we have optimized the input. The goal is to frame the prompt in a way that guides the model towards producing the desired output. And 3, iterative refinement. Often prompt engineering requires trial and error. You can analyze an output and adjust the prompt to get an even better output. Another thing to be aware of when working with large language models, in particular, is the ability of large language models to learn from information in the prompt itself. This is known as in-context learning. To illustrate this, I have 2 types of prompts here. The first is known as zero-shot learning, where I asked ChatGPT a simple question: who won Super Bowl 50? In the response, it responded in a few sentences, providing the team's final score and the date it took place, which is fine. But in the second example, known as few-shot learning, I provided ChatGPT with some examples of how I would like the response to be formatted directly in the prompt. And it responded in that format. This is significant because it can reduce the need for extensive retraining of these models, which take time and resources. So some prompt engineering best practices. First is to always be clear and specific in your prompts. For example, instead of writing, make a schedule for project manager, write, create a detailed daily schedule for project manager overseeing a construction project, include the time blocks for team briefings, site inspections, client meetings, and document updates. Another tip is to provide context and examples within the prompt to guide the model. So instead of writing, write a response to a customer complaint, write a customer service email response where the customer's complaint about a daily shipment is acknowledged sympathetically, and they're offered a 10% discount on their next purchase. Begin with dear customer name and ensure the tone is apologetic and understanding. And finally, another important one is to define what to do if the model can't answer confidently. This is an important one because it can prevent the model from hallucinating and making something up. So what you could do is start the prompt with something like, please provide an answer to the following question. If you're not confident in the accuracy of the information, if the data requires to answer is not available in the training, please respond with I don't know, and then proceed to ask the question you're looking for. And with that, I'll pass it over back to Blake to talk more about using generative AI.
Yep. Okay, thanks. So far, we mentioned that large language models are trained to predict what's next in a sequence based on what came before it. But you're probably thinking, interesting, but how does this help me understand how to use it? Raul just spoke about how to get the best results from using prompt engineering, and I'm going to expand by saying specifically under what conditions to use generative AI. Where does this advice come from? For that, I'll give credit to my classmates, podcasts, and research papers. This is a synthesis of many hours reading and debating papers in class and listening to podcasts. So these ideas are not just our own, we're just retelling the story. And there's one big point to establish before saying how to use generative AI. The biggest limitation of using these language models today is the AI hallucination problem. That's what people call it when AI says something subtly wrong, misleading, or altogether false. To make the examples clear, I'll be focusing on language models, but these same principles apply wherever you're using generative AI systems. In this slide, we see that ChatGPT is being tricked into saying something false. This and other examples like it are why you should always check the output of language models thoroughly. If you understand this principle, all of the rest of this talk will be clear. Depending on the language model, anywhere from 3% to 27% of generations can contain some form of hallucination. At the bottom of the slide, you can go to this link for a leaderboard of which models have the lowest rates of hallucination. Now on to the tips. First, a good rule of thumb. Use generative AI when searching for something that's hard to find but easy to check. This rule is a bit abstract, so let me give an example. Imagine you're writing and you have the perfect word on the tip of your tongue, but you can't quite remember it. Instead of shuffling around with a thesaurus, you can ask ChatGPT what words describe this situation. Then you can check the definition and make sure it's correct. Second, learning with personalized explanations. Let's say you're reading a textbook or trying to understand something new, and it's just not clicking. But you can't talk to your textbook. What you can do is you can retype a specific sentence to ask for explanations or analogies. To a large language model, there's no such thing as a stupid question. Third, getting ideas related to a new concept or theme in creative contexts. If you're in a writer's block and you don't know where to go next, you can just ask a chatbot what to do next, and you might be surprised by the ideas it gives. Use it as a starting point and let your creativity flow from there. Finally, language models are fantastic at summarization. Taking a large text and pulling out main ideas can allow you to get what you need out of a text in less time. Just keep in mind that every summarization removes details and nuance. We know the audience here today has all sorts of people, so let's add a few more examples. Let's say you're trying to get a summer internship as a student. Then resume critique makes sense for you. If you're writing, asking for grammar suggestions and style feedback is a great way of spotting places you can investigate later. If you're a developer, using a license-approved language model to write unit tests can speed you up. And of course, check your line coverage to be sure everything is working as you expect. If you're at work and you need notes during a meeting, you can use speech to text and even summarize the output with the language model later. And just like any technology, there are cases where generative AI is not the right tool for the job. With the knowledge of the hallucination problem, these are the conclusions we can logically deduce. First and foremost, critical systems should not use generative AI. This means any hiring decisions, granting loans, and any situation where nuance really matters should be taken with human care. Critical decisions made automatically with AI is firmly in untested legal waters today. Next, don't take investment advice, legal advice, or medical advice from language models. Remember, today's language models have no special machinery for truth. Third, to drive home our theme about the training process, we can understand that since the model was trained to predict what comes next, there's no reason for it to excel at exact calculations. Language models, which aren't explicitly trained to do math, are bad at math. And one more thing, the copyright landscape is rapidly evolving. If you're using a language model and trying to sell something, today, your work might not be copyrightable. At worst, it may be a breach of your agreement with the provider. If you're selling a product, read your end user license agreement. And if you're in doubt, ask your lawyer. Given the hallucination problem, you're probably wondering if there's a way to increase reliability. Fortunately, there's an answer for that. Whenever you can, use systems that search the web and other documents to provide citations. This has the fancy name of retrieval augmented generation. As Raul spoke about earlier, models take weeks or even months to train. So if an event occurs in the meantime and was not in the training data, the model won't have any real information about it. This is what folks call the knowledge cutoff problem. Using retrieval augmented generation fixes that too. Since new information is pulled in right before your question is answered, these systems can answer questions based on recent events. It also increases factuality because these models are less likely to answer a question incorrectly when it was just given text containing the correct answer. Finally, it's easier to check the source because the model output will often contain references that take you directly to the document or website which contained the answer. Okay, so how can you tell if a system is using retrieval augmented generation? Look for citations and references. For example, Consensus AI is a site that researchers can use to get reliable answers while citing academic papers. This means those researchers can explore the landscape of academic papers more quickly and create more time for specialized work. And critically, every response contains many citations to check the facts. We know this AI system is using retrieval augmented generation because it provides specific citations for the answers it gives. Okay, let's suppose you want to start. What should you look up today? I'm going to quickly show this screen, and we can also share this in the chat. This can be a cheat sheet for you to use to remember the takeaways from today's talk and added resources for you to learn more. In the first column, we have the language models that you're able to use today. In the second column, if you're a developer or developer in training, everything in the first column is relevant. And here are some additional resources and keywords for you to search for. Finally, there's a ton of resources available for free online. These run the gamut from getting new ideas on how to apply generative AI all the way down to the mathematical foundations of deep learning. In this presentation, we started with a few examples, got into the science, and finally, we explained how to use generative AI in practice. Like I said, AI is a really broad discipline, so there's a lot we didn't cover today. But we hope this gave you a starting point for future exploration. That's all. Thanks for listening. I hope you enjoyed, and now we can transition into questions.
Awesome. Thank you both so much. My name is Autumn Trapacante. I work here with my better half, Doug Haber, on this series. I'm also a software development manager at Audible. I know Darren was having some audio issues, so before we get into Q&A, Darren, was there anything you wanted to share about?
So Autumn, can you hear me now?
Yep, you're good. Thank you so much, Darren.
Oh, great. Thank you. So is it my turn to
Yeah,
just thank Audible like so much for putting all these important talks and really taking it like at deeper levels than if just indiscriminately YouTube many of the topics. And obviously the thing added to these customized talks that you guys give is this Q&A back and forth, and it really just gives some people an opportunity to ask these important questions. So I really appreciate the collaboration that we have with Audible, and then I hope it continues. But I do have just like one general question I want to ask. So do you think with the evolution of AI, and I picked up this book called The Coming Wave by Mustafa Suleiman, and so do you think that just from deep fake to like all the other things that could be used in a malicious way, I could be like on my computer, that I can have like breaking news with somebody like Jake Tapper or somebody else who is like respected in journalism, that that China just fired an ICBM missile, and this is what, and then have a conjured up AI picture of a missile hitting some geographic location, and all the checking that we should be able to do, but just in real time, and then add to it, it really just goes viral, that it really creates like such an incident, to be able, that people are just frantic, and it's really hard to kind of like dial that back. And if that is possible, like right now, how do the tech titans and I know that Elon Musk was on record saying that this is the thing that you've got to put guardrails around. And if you don't, from what I just described to cyber warfare with, folks and countries that own nuclear weapons. So like, what is your big, like long-term view about, and that genie is out of the bottle already, but just in terms of, are you optimistic that AI on balance is going to do more good than harm? I'm interested, you and members of your team, like what do you think, given that you can't stop it?
Yeah. So I can start answering this question, and maybe we can go around. But there's a so I know about this from the experiences I've had in my master's classes at Columbia. I know that there are a lot of people working hard on a couple different prongs to attack this problem. One of them is alignment research, which is the broad category of research that basically tries to make all these kinds of AI systems as harmless as possible. And Raul covered a little bit of this in the example where he asked about like robbing a bank. That was a like soft hypothetical example, but in practice, a lot of these companies very, very, very like rigorously, they do what's called red teaming, which is they give a bunch of people objectives that they don't want the model to do, and they're trying to see if they can trick the model into doing those undesirable behaviors, and then they patch it out. So that's one of the prongs. Another one of the prongs is making certain types of generations like illegal for people to create and disseminate. So that's another prong I'm aware of. But yeah, this is a big a big question, and part of the purpose of this presentation is to bring awareness to how realistic certain things can get. One other thing I can cover here is that like the OpenAI Sora video example I just gave, they they've done something very interesting with the way they're deploying it. So they announced this and they give these demonstration videos really early, but currently, to my knowledge, like there's no public access for Sora. And I think what they're doing is they're priming us and they're kind of letting everyone know in advance, hey, this is what's already possible today. We're not even going to give anyone access, but we're going to prepare everyone. So yeah. And then one last thing that popped into my mind is there is a bunch of things that social media companies are doing to both automatically detect AI generated content and automatically flag it and like penalize accounts that disseminate AI generated content without properly marking it. So, like I said, it's a multi-pronged attack, and I think, well, I hope that we all as a society like take a mature look, do not underestimate these systems, and rationally assess the risks and how to mitigate them before things get like too far too quickly.
That was a great answer, and I would just add one thing to that, which is that we're at this interesting convergence of social media. Like if anyone's familiar with the War of the Worlds broadcast, back in the was that the 30s? Yeah. There's it's been told that it created mass hysteria, which it later turns out it didn't, but nonetheless, that was an instance where people tuned into a radio broadcast that sounded so much like a real radio broadcast that people panicked, or at least some people did. And we're at this point now where social media, a lot of people get their news from TikTok, and if one of these videos were to pop up, you can quickly see how it could create a lot of problems. So just don't trust what you see on social media. Go to news sources that have been around for a long time, that are trusted, that verify, and always go to several. Make sure that the information that you're seeing is consistent across the board. So that's just like a general tip about this kind of stuff. But getting into some more Q&A, and that was a great question, Darren. I was wondering if we were going to touch on that, but sort of more generally, first question is, we say generative AI is better, or is getting better, but hallucinations seem to remain a problem. What can be done to counter models generating something that is non-existent? You talked a little bit about that, but would either of you like to expand on it?
Yeah. So the this is a very good question. So there's a lot of ongoing research that is just like every week there's like a bunch of papers that come out about addressing the factual consistency. So it's like there are a bunch of metrics like faithfulness and then like accuracy and all of that kind of stuff. And people formulate ways to automatically measure hallucinations, because as soon as you can measure something in a deep learning system, you can optimize for it. So you can penalize the model for hallucinating, essentially. And there's a lot of ongoing research in academia today about this specific problem. And I don't think, factual consistency could be like completely eliminated, but I think my view differs from the average person's view of this, because I've seen just how quickly these systems are evolving. So with that, I'll summarize by saying today it's a problem, but tomorrow these systems might get more and more factual. So incorporating retrieval augmented generation is like just the first step. But even after you do that, there's still like lots of open research to measure factuality and then optimize for it. Just like reinforcement learning with human feedback, you can incorporate factuality as one of the things you're optimizing for. So it's I would say today, take everything you see with a grain of salt, and I would say that shouldn't ever change. You should always, have like media literacy and critical thinking skills active. But tomorrow, the blatant like incorrect hallucinations we see today might become a thing of the past.
So you mentioned doing some of this kind of augmented learning where AI is creating, information to then, train other
Yeah.
AI. Matthew asked a great question about, we obviously, where's the question? If we fed the entire internet to these things, but if we use something like, augmented training and learning, how do we prevent, or what's being done to, prevent a feedback loop from occurring where it just starts degrading their accuracy and performance?
Yeah. Do you want to?
Yeah, I think if I understand the question correctly, I think this what they're trying to do as far as like creating synthetic data, um, it's like they're not like running out of information to feed these models, but it could be more using like synthetic data. You could have more control of the data that's being fed in, so it won't be like as random, and that could kind of improve its training. So I think kind of that's like the lane they want to when they want to go when talking about like synthetic data is have using more tailored training data on these models, which could reduce things like or in essence just makes them more smarter, because just using just some random data from the internet, for example, it serves its purpose, but it could could train on like unrelated or gibberish that's not doesn't really add value. It adds some value, but if you had like some tailored data to train on, I think that would be better. So I think that's if I understood the question.
Yeah, no, that was great. More general question, how are the two of you using these tools in your day-to-day, both, at work and outside of work?
Yeah, me personally, at work, I mostly use it in the form of using Amazon Code Whisperer, which is this tool that AWS developed. We have access to it here at work, so it's like a coding companion, which could assist you in writing code based on the context of the code you're writing. You could kind of speak natural language English, and it'll generate the code for you. So I think that's personally, that's where I use it the most. And then like my outside of work, like I have ChatGPT. So if I encounter like a specific topic, instead of like going on Google and doing research, I could just ask it to explain it to me like in simple terms, in bullets. That kind of gets me to kind of an answer quicker.
As for me, I use the Amazon internal chatbot. That one is backed by Claude, and the example I gave about writing unit test, that was a personal example. I use it all the time for that. I find these unit tests often boring, so as many of them as I can automate away, I'm happy to. And it gives me more time to just like get that extra line coverage, like cover that extra edge case, because increasing the reliability of your code will pay dividends in the long run. So it takes away the silly tests that the ones that you need to cover just because you have to, and then it gives you more time to spend on working on the edge cases and getting your line coverage to as close as 100% as possible. So that was my personal example.
Yeah, everyone seems to have laughed on the unit test comment, and for those of you on the call who aren't developers, it's because unit tests can be extremely dry. You mentioned the chatbot, the internal chatbot, so that's a great segue into a question that came up for those of us who work at Amazon. But is there any Amazon all-purpose chatbot that folks can use on the Amazon network? And so any resources you provide for those of us who'd like to start utilizing that?
Yeah, they probably like a month ago, they kind of release Bedrock for like internal use or cleared it. So thing requires manager approval to gain access to it. But once you get manager approval, we could provide the link. Yeah, and yeah, once you have that, you have access to all the models that Bedrock. Most of them. Some are still not yet released, but yeah, you could use that. You could actually use it at work. I know other systems like ChatGPT are not allowed to use at work. So using Amazon Bedrock, we could use it like with our proprietary information and things. So
Thank you. I took some notes on that. So another question around just tooling is, you talked about ChatGPT. I know there was a slide, different resources that people could use, but in addition to those, are there any resources specifically, maybe YouTube channels or blogs or things like that, that somebody who wanted to start learning more specifically from scratch about prompt engineering that they could go to?
yeah, and that last slide we have some YouTube links there. We'll provide the links, but that one's really good on prompt engineering. This was from AWS reInvent last year. Kind of go more deep into details on it.
Yeah, and for me, I'm the one who added this bullet point because it's actually really wonderful what MIT has done is they've made their like deep learning lectures completely available to the public, and this is what I use to learn, especially in undergrad, about deep learning, and the lectures are really high quality, and you can even find problem sets to do. You can get like a MIT level understanding of these stuff from the albeit academic and theoretical perspective. You can get that even on YouTube, which is surprising. So that's what I usually do when I want a refresher.
So along the same lines, a question that I thought folks might be interested in is, this is obviously a very intimidating space to get into. The concept is new. It's if someone was wanting to get into AI development specifically, would that be a good route for them to start? Like looking at, I know that you mentioned you're taking courses at Columbia, for example. Maybe do you want to share a little bit about how you, how you found out about that program, what led you to it, how you, what that process was like? If someone wants a more formal route.
Yeah. So for me, I'm a master's student at Columbia, and I applied because I was really interested in continuing my education on AI. I had like scraped, very surface level stuff during undergrad, but I took all the classes that I could in undergrad, and then I worked on a summer research program, and that program is what trained me in some machine learning stuff and allowed me to apply and get in. But I think if you're actually trying to build something today, it might be just as easy as like going to like YouTube is pretty much the resource that even I've used. And I put this on the slide as well. There are a bunch of like open models. So there's like open weight models, and there are models that are like open source, but all of the licenses are kind of unique. So these words apply differently according to different people. But the point is, it's free for you to get started with if you're a student, and you can even train your own, like compile your own data set, and then you can even fine tune your own pre-trained model, all without paying a single cent. I mean, you'll probably need some GPU power or some computer to run it on, but if you're going if you're interested in going to that angle of it, it's actually very accessible, like surprisingly accessible. And yeah.
Yeah, great. I was hoping you would get at that because I feel like people often think that you have to go to university to start working with this stuff, but there's actually so much stuff that you can start using today that's super accessible. So maybe one last kind of like very heady question, which is how can the tech community address the huge ethical concerns surrounding Gen AI, copywriting, misinformation, bias, cheating, learning, using others' likenesses without avoiding it entirely? And we're all looking to you to solve that that question for the ages. Or if, maybe more specifically is, are you aware of sort of things that individual companies are doing? You alluded to social media, taking some steps, but any kind of thoughts on that? Can also decline if it's a little too hot of a topic.
Yeah, I think just as like this field is getting more bigger and bigger, there's also we touched on a little bit development of a system that could like detect AI generated content. I know like universities have this where they feed like, let's say, a student's paper, and it could kind of detect whether they use AI in some form or not. So just as the field continues to grow, there'll be like kind of systems to kind of counterbalance that. I think that's like my opinion.
Yeah, it's a very big question, and like I admit, like we probably don't even have enough time to get into all of the facets here. But yeah, like Raul mentioned, there's like just as people are using it to like cheat, also like companies like Turnitin are actually making AI detectors, and Turnitin is already a well-integrated system in universities. So they're developing their own AI to dissuade students from completely cheating outright. And then it becomes, that acts as a little bit of a balancing force. But the bigger picture stuff about like the ethics overall, I think that's a lot of like, it's a very philosophical like a philosophical question, and I don't personally have I see a lot of different sides, and I listen to a lot of different commentators, whether it's like podcasts or YouTubers. So I think one thing we will probably like all experience is like civic engagement and like participating in the democratic systems that will make certain things like illegal. Like I just heard the other day that the UK made certain deepfakes like illegal to produce and disseminate. And I think that's a step in the right direction. And we'll definitely need to like continue doing things like that. And I think that's pretty much all I can say with any amount of confidence. Everything else is like very theoretical and very philosophical. So I'll leave it to the specialists on that one.
Yeah, no, you brought up a really great point, which again I was hoping you get to, about civic engagement, which is the one I was reading about. I think it was just last month, was the Elvis Act, which was passed in Memphis, Tennessee, which basically made it illegal it stands for the Ensuring Likeness, Voice, and Image Security Act. So it was signed into Tennessee law, and it essentially made it illegal for people to reproduce or to monetize and use artists' voices. So that obviously has happened. If anyone's familiar, there was some songs that came out with popular artists like Drake and stuff who were actually didn't obviously make that song, that got really, really big very quickly. So I think, as you said, at the end of the day, the best thing people can do is really make it known that this is something that's important to them, and governments are going to have to, create regulations just like they do with any other industry. So maybe we'll put the ethics conversation, we'll table that for now. I believe that was the last question, but maybe one just for fun to end on a high note is and if you don't have an answer for this, that's fine, but what's maybe like the silliest or the most frustrating hallucination that you have had for, recently or in the past, couple months that you can think of? Not to put you on the spot.
Oh, I can start. So a little bit of background. It was like last fall. I was taking natural language summarization and generation and summarization as a class, and we actually got assigned to use ChatGPT for our homework, and like the assignment said, hey, use it to do a preliminary literary review, like use it to find out what research topics you can have, and like what people are saying about these research topics, and what exciting avenues for new research there are. And I remember it made so, and the assignment was like, okay, after you did that, actually do your literature analysis and like actually check, right? And I remember seeing something like really exciting. I'm like, oh my gosh, that's so cool. And then I look it up, and it's like not a thing. So it hallucinated this idea, but then I'm like, oh wait, this is a new idea. I thought it was cool. Oh, okay, then I can actually like investigate if that's a feasible like research avenue to put time into the research project. So it's kind of like using hallucinations for good in that situation. But it was funny because yeah, it made up like a paper name and a bunch of authors, and then like probably today it would say, hey, I can't tell you specific authors because it got patched out.
Yeah.
And the system got improved. But yeah, that was a funny hallucination that I experienced, and I called it out in my paper. I was like, yeah, this is total nonsense, and yeah.
That's great. Thanks.
Yeah. For me, actually, when working on the presentation, I was using DALL-E to generate an image for one of the slides, and I wanted like a neural network that showed kind of text going in, changing to numbers, and it just generated like some gibberish. Like it wasn't even like, I don't even know if it was text or not. It was just like a whole bunch of symbols and stuff. So that one like comes to mind, which I experienced while working on this. So I think the like text to image space, I guess that was like a form of hallucination in that aspect.
Yeah, thank you both. So yeah, we just have a couple minutes left, so I think we'll close it out. So thank you both very, very much. This was such a great presentation. Thank you everybody who worked behind the scenes to make this happen. To Darren and your team for helping organize this as well. This is I guess has turned into one of my favorite things every month. So very much thank you for that. Quick reminder, our next talk will be on May 28th. We'll be covering cybersecurity. That's going to be also a great conversation, and there will be a lot of really good practical tips there for you as well. Security is something that we all probably should be doing more of all the time, especially with AI sort of becoming integrated into that space. So again, thank you to everybody who joined. Hope everyone has a really wonderful rest of your week, and we'll see you next time.
Thank you.
Thank you.
Thank you, guys.
Thank you, guys.
Yeah, nice.